This is the first of 3 videos that cover the information in Chapter 2. Chapter 2 is concerned with descriptive statistics, and in particular, tabular summaries of data and graphical summaries of data. The material is broken into 3 different parts. First, techniques that are appropriate for summarizing data that's categorical, and you will recall that categorical data uses labels or names to identify like categories, and summarizing data for quantitative variables. That's the second key topic of this chapter. And quantitative data are always given to us as numerical values and indicate how many or how much of something. The last part of this chapter, which will be covered in a third video, is concerned with summarizing the relationship between 2 different variables. In this chapter, we will cover a frequency distribution, which is a tabular summary of categorical data, a relative frequency distribution, and a percent frequency distribution. The last 2 are actually derived from the first one, and each one of these tabular summaries of the data is very similar and can often all be represented together in one table. The information that's in a frequency distribution can be represented graphically in a bar chart. Your textbook also covers pie charts. I am not fond of pie charts, and they will not be covered in this video. A frequency distribution is a tabular summary of the data. One question that naturally arises when we have categorical data is how many observations fall within each one of the categories or classes. That information is captured in a frequency distribution. The frequency is simply the number of observations that fall within each class. The objective of all descriptive statistics is to provide insights into the data that are not apparent if you just look at a spreadsheet of data and a large number of values in a data set. So an objective of descriptive statistics is to really pull out the key aspects of the data and start to learn about your data set. Here's an example of a frequency distribution that comes from the Walmart data set that we used in the last 2 videos. You will recall that the Walmart data set had a categorical variable called isHoliday, and isHoliday was set equal to false if the week in question did not include a federally recognized holiday, and was set equal to true if the week did include a federally recognized holiday. There were a total of 143 weeks in that data set. 133 weeks did not include a federally recognized holiday, and 10 weeks in the data set did. So the frequency, the numerical count of the number of weeks where there was no federally recognized holiday, was equal to 133, and the frequency associated with isHoliday equal to true is 10. This table also represents the relative frequency, or the percent relative frequency in this case, since there's a percentage here and it's not expressed as a decimal. These percentages are calculated by taking the frequencies and dividing them by the total number of weeks. In other words, 133 divided by 143 is 0.93. 0.93 times 100, so it's expressed as a percent, is 93%. Likewise, 10 divided by 133 times 100 is equal to a 7% relative frequency. 7% of the weeks in the data set included a federally recognized holiday. And you can see, of course, that the relative percent frequencies add up as they should to 100%. The relative frequency, then, of a class is the fraction or proportion of the total number of data items that belong to the class. The relative frequency is equal to the frequency in the class divided by the size of the sample. A relative frequency distribution, then, is a tabular summary of a set of data that shows the relative frequency for each class. A percent relative frequency is very similar to a relative frequency distribution. We just take the numbers and eliminate the decimal point by multiplying by 100. A percent frequency distribution is then a tabular summary of the data that shows the percentage frequency within each class. Here's an example. Suppose we're working for Murata Inn, and guests staying at the inn are asked to fill out a survey of their experiences, and they rate the quality of their experience at Murata Inn as being in one of these categories. This is clearly a categorical variable. They can rate it as excellent, above average, average, below average, or poor. These naturally provide the classes on which we will divide up the data and count up frequencies. The ratings provided by a sample of 20 guests are as follows. You can see that some are below average, some are above average, excellent, etc. But just simply looking at the data, it's hard to make a determination about the overall quality of the accommodations at Murata Inn. So we will use some descriptive statistics. We will build a frequency table where the classes will be equal to excellent, above average, below average, and poor. Here's a count of each one of these surveys that fall within each category, from excellent all the way back to poor. So 2 people had a poor experience, 3 people had a below average experience, etc. Until we get down to excellent. 1 person indicated they had excellent accommodations. And of course, if we add up all of the frequencies, we should come up with the sample size of 20. Here's an example of a relative frequency distribution and a percent relative frequency distribution. In order to calculate these 2 frequency distributions, we took the frequencies, or the counts, from the previous table and divided them by 20. That is the total number of observations in the data set. So example, we had 1 individual who had an excellent experience, so 5.05 is equal to 1, the frequency, divided by 20, which is the total number of observations in the data set. Doing that for each one of the entries in the frequency distribution, we get the relative frequency distribution. If we add up all of the relative frequencies, they should total to be equal to 1. Likewise, to get the percent relative frequency distribution, we simply take the relative frequency distribution and multiply each value by 100 to express it as a percent. So here we have 0.1 multiplied by 100, which is 10%. So if we add up all of the percent relative frequencies, we should of course end up with 100%. Bar charts. Bar charts are basically a graphical representation of the same information that we put together when we looked at frequency, relative frequency, and percent relative frequency distributions. On one axis, usually the horizontal axis, but it doesn't have to be the horizontal axis, we can have a sideways bar chart also. But on one axis, we specify the labels that are used for each one of the classes. A relative frequency distribution, a percent frequency distribution, or a frequency distribution is then used on the vertical axis. This gives us an idea of the distribution of our data, or how our data is distributed across all of the different categories. It's typical to use a fixed bar width drawn above each one of the classes, where the height of the bar is equal to either the frequency, the relative frequency, or the percent frequency distribution, depending on the scale that we prefer to use in our bar chart. Here's a bar chart of my isHoliday variable in my Walmart data set. And it's easy to see from the graphical representation that most of the weeks that are in the data set do not include a federally recognized holiday, because this bar is associated with is holiday equals false, and the lower bar is associated with is holiday is equal to true. I would also point out that what I put on the vertical axis is the frequency here, not the relative frequency or the percent relative frequency, though I could have used those scales instead. Here's a bar chart that represents the Maratha Inn quality ratings from those 20 surveys. Again, the frequency was chosen on the vertical axis, but there's no reason why we couldn't use percent relative frequencies or relative frequencies on the vertical axis. Now it's easy to see from the data that most of the people who visit Maratha Inn seem to give an above average rating to their experience at the Maratha Inn. 1 is excellent, most seem to fall in the above average category, and many seem to fall, 5 seem to fall in the average category, and overall only 4 fall within the poor or below average category. So it's a lot easier to discern information from our data set when we use these descriptive measures as opposed to just looking at the raw data.